Today we are going to have a design thinking discussion on shift register. So we all know what is design thinking. So design thinking is a process of understanding the needs of a user. Totally we have 5 stages over here: empathy, define, ideate, prototype and testing. So we are going to apply all these 5 stages on the shift register and we are going to find out the outcome. So let's start the discussion.
So good afternoon. As we have gathered here, let us discuss the shift register on the DT approach. So how can we design an electronic device that can store the data as well as transfer the data bit by bit? The answer is shift registers. These shift registers are electronic devices that can store the data as well as transfer the data or shift the data from left to right or right to left based on their requirement.
So shift register is for storing the data as well as shifting the data based on the requirement of the user. So now we are going to apply 5 stages of design thinking on the shift register: empathy, define, ideate, prototype and test, and we are going to come out with a solution for a problem statement.
So hello everyone, I am here to talk about the empathy part. So empathy is the first stage of the design thinking which understands the user needs. Here is our need is temporary data storage for the microcontrollers and the requirement of serial to parallel or parallel to serial data conversion, and its applications are LED display, digital communication and memory buffering. So for example, in embedded system the sensors send data through serially.
So empathy part, we are going to understand what is the need for data transfer and how the data have to be transferred. Whether it is a serial communication or parallel communication, whether we have to transfer the data from left to right or from right to left based on the requirement. So next, define part.
So I am going to explain about the define part. Define stage clearly identifies and describes the core problem that we need to solve. So after understanding the user and the system needs, we need to frame a problem in the define stage. For a shift register, the problem statement that we can define is to design a circuit that stores and shifts data in the proper direction with the proper synchronization. This mainly focus on important requirements like number of bits to be stored, to shift the data whether in right or left, clock control, and the types of inputs and outputs, whether it is serial or parallel.
So in define stage, we are defining a problem statement. So the user has to define whether the data has to be transmitted from left to right or right to left, and how many bits have to be transmitted, and whether the data has to be transmitted in a serial manner or parallel manner. So these are all defined in a define stage. Next one, ideate.
So after defining the problem, we are here to ideate the solution for this problem given. So actually there are 4 types of shift register: serial in, serial out, serial in, parallel out, parallel in, parallel out, and parallel in, serial out. So these types of shift register are used to shift the data from left to right or right to left. Actually there are also 4 types of flip-flop: D, JK, T and D. So according to the problem which happened to the user, he can use the type of shift register used to be, and also this is termed as one of the most efficient way to transfer the data from right to left or left to right in the digital systems.
So here in ideal stage, we are listing out the various type of shift registers. So in, serial out, data will be sent in serially and it also retrieved serially. In serial in parallel out, data will be sent in a serial manner. So immediately the data can be retrieved. So serial, next one is a parallel in parallel out. Data will be sent in parallelly and also recovered parallelly. And next one is parallel in serial out. Data will be given parallelly, but it can be retrieved only 1 bit at a time. And also Subhas discussed about the type of flip-flop, right? J, T, JK and SR, and the most widely used is a D flip-flop. We all know the operation of D flip-flop, right? Whatever we are giving inside, we will be getting as an output. So this is most widely used in case of the shift register. And next one.
So the prototype is that to build a simple 4-bit shift register using D flip-flops and to simulate using Proteus or multisim to observe the shifting actions, and then test the shiftings of bits on each clock pulse to observe serial and parallel operations.
So the shift register, all the flip-flop will be connected in a cascaded manner. So data will be transmitted from left to right or from right to left based on the clock pulses. And we can build the shift register and we can simulate the particular shift register using the multisim. Okay, software used is multisim. Next one.
Here is the last stage of design thinking, which is a test. We are here to, here is a test to verify the functional correctness or the bytes in a shift registers are in correct direction. Is timing synchronism is in correct way or the power and speed are meeting together.
We all had a discussion on design thinking approach on shift registers. We have discussed what is the introduction part for the shift register and we have applied stages like empathy, define, ideate, prototype and testing on the shift register. And we have discovered the problem statement and we have defined the problem statement and we have listed out the ideas and finally we have even discussed about the prototype part and finally the testing part. So while applying this design thinking approach on shift register, we can improvise the shift register and we can give a more user-based outcome. So we all know shift register is used in data communication. So while employing this design thinking approach, the communication will be more effective and more purposeful. So thank you all for your valuable points. Thank you.